In this video, we're going to introduce the idea of a z-score. So as you can see, it says a z-score is a number that tells us how many standard deviations away a data point is away from the mean. Okay, so what happens basically if we go back to our picture from the empirical rule? We had our x bar in the middle, and then we'd walk out 1 standard deviation, 2 standard deviations, -1 standard deviations, and -2 standard deviations. Okay, so you'll notice I didn't write the s's to the side like I did in the empirical rule, and that's because when you're talking about z-scores, what's happening is that if we wanted to make these be basically the unit of z, this would be -2 z's, -1 z's, 0 would be x bar, 1 and 2. Okay. How this works basically is that if we were told that we had a mean temperature for the summer, let's say summer months, and I was told the mean temperature was 85 with a standard deviation of 5. We'll keep it simple. Okay? All right. What that is saying is that if we were to basically go to this picture, we're saying that here 85 would be in the middle. If I walked 1 standard deviation, walking 1 standard deviation would be adding 5. So if I take 85 and add 5, I'd get 90. Okay. So then if I walked another standard deviation, so another 5, I'd get 95. All right. So if I relate this to z-scores, what it's saying is that a temperature of 90 degrees is the same thing as having a z-score of 1. And a temperature of 95 degrees would be the same as a z-score of 2. Now, some of you may be thinking, well, Jen, could you do 3 z-scores? Sure. If I want to do a z-score of 3, it says that I'm walking out that standard deviation 3 times. So here, if I were to walk out 1 more, it's saying that a temperature of 100 degrees would have a z-score of 3. Okay. So if somebody told me that I had a z-score of 3, that 100 is a z-score of 3, what that's telling me is, whoa, for wherever it is that I'm talking about, 100 is an unusual temperature. Whereas if they told me that a temperature of 90 has a z-score of 1, being within 1 standard deviation is this middle mountain. Whereas out here, as I move past, basically right around 1.5, as I'm moving this way, I'm starting to creep into the tail, and this is where I'm getting more unusual values. Okay, now, it sounds weird to talk about negatives here, but we do talk about negative z-scores. Because what a negative z-score is it's saying that it's below the mean. Okay, so we're not saying we have negative temperature, we're just saying that if I were to subtract 5 degrees, I'd have 80. So a temperature of 80 degrees relates to a z-score of -1. -1 is telling us that it's 1 standard deviation away, but the negative is saying to the left or below. All right, so if I was to walk another standard deviation down, so if I was to subtract 5 one more time, I'd be at 75 degrees. So 75 would relate to a z-score of -2. Okay. Now, if I asked you, hey, what's a z-score of -3? What temperature has a z-score of -3? Well, what you'd want to think about is that negative means I'm below. 3 means 3 standard deviations. So I'm going to go 1 more, subtracting 5, and that would be 70. So here, 70 degrees. All right, now, again, we're going to keep talking about z-scores as we move further along in this book. But basically, a good rule of thumb is that if you are basically between -1.5 and 1.5 z-scores, you're sort of in the middle group, you are typical. You're not weird, okay? As I start to creep past 1.5 z-score, so as I'm creeping towards 2 and 3, or -2 and -3, I'm now in the tail. I'm a little weird. Weird isn't bad, but we're just saying we want to know, hey, is this score unusual or is it typical? And so z-scores are a way that we can generalize it no matter the topic. Okay, good luck.